On a particularly rainy day, Annette checked her rain gauge throughout the day. Her observations are recorded below. So here we have some information about the various times that she checked the gauge and how much rain was in the rain gauge. We can see that there's inches there. And they tell us below the table, let G be the amount of rain in inches in the rain gauge T hours after 10 a.m. Then we're going to do a couple of different things with this information. We're going to create a scattergram of the data. We're going to use this hint about using a common denominator of 8 for the fractions. And then that will allow us to scale our g-axis by 8ths. Then we're going to draw a line that contains the data points. So we're going to create our linear model. We're going to estimate the amount of rain in the gauge at noon. We're going to predict when there will be about 1 1/8 inch of rain in the rain gauge. And then we're going to talk about the g-intercept. So let's go ahead onto a piece of graph paper here and see how this is going to play out. So notice that I've already done some work here. I've gone ahead and written down each of the times that we were given in the original table, and I wrote down how many inches were recorded. And then the ones that do not have an 8 denominator yet, I went ahead and set them up. I built those fractions so they all have an 8 denominator now. And then that allowed me, when I came over to do my axes on my graph, that on my g-axis, you can see that I've scaled by 8ths. Now I only labeled every other line because it's awfully tough to squeeze in a whole bunch of fractions if I put numbers on every single line. So this line would be 1/8, but I didn't label until 2/8. This is 3/8, then 4/8. 5/8, then 6/8, and so on. Notice I didn't write 8/8. I went ahead and put the number 1, and then I kind of started with my mixed numbers from there. Now on my t-axis, I want to be sure that I use the information from the problem. They told me that t was going to be hours since 10 a.m. And so these numbers here don't refer to particular times. They tell me how many hours since 10 a.m. So let's go ahead and get our scatter plot on here. So we're going to go ahead and label plot these points. So at 10 a.m., which is 0 hours since 10 a.m., we have 3/8 of an inch. At 11 a.m., we have 4/8, and so that's going to be 1 hour since 10 a.m. Now we jump up to 1 p.m., and 1 p.m. is 3 hours since 10 a.m. At 1 p.m., it was at 6/8 inch, so we're going to go up here to 6/8. And then finally at 2 p.m., that would be 4 hours since 10 a.m. At 4, we would want to go ahead and put that down as 7/8. So those are my data points. And we're going to use our straight edge here to create our nice little linear model, because we can see those points all fall in a nice straight line. We're going to go ahead and get those pieces in place. And now that we've done that, we can start answering some questions. So the first question is, how much rain would we expect would have fallen at noon? Well, noon is 2 hours since 10 a.m. So if we follow that information up to our graph and then cut over here, we can see that's going to correspond to 5/8 of an inch. So we'll go ahead and put that information here. 5/8 of an inch had fallen at noon. When would we expect that 1 1/8 inch had fallen? Well, 1 1/8 is up here between 1 and 1 2/8. So we'll see where that hits our graph. Hits it right there. We're going to come straight down. We're going to see that that's at 6 hours since 10 a.m., so that would be at 4 p.m. And then the final question about the g-intercept. Remember, the g-intercept is where my line is going to hit my g-axis. So that point is right there. So the g-intercept itself is the ordered pair 0, 3/8. And if you remember from when we created this, that this is hours since 10 a.m., so 0 hours since 10 a.m. tells us that at 10 a.m. there was how much rain? Well, 3/8 of an inch, and that was actually one of the data points we plotted. So we can say that, what does the g-intercept mean? It means that at 10 a.m., 3/8 inch of rain was in the gauge. And so that answers all of the problems that we have for this particular problem. And there's our nice little scatter plot all finished up.